Suppose that a sample of 20 employees at a large company were surveyed and asked how many hours a week they thought that the company wasted on unnecessary meetings. The data in hours is shown below. We are going to calculate an 89% confidence interval to estimate the mean amount of all employees at this company believe is wasted on unnecessary meetings each week. And we're going to round answers to the nearest hundredth. Now, in previous examples, I went over with you a lot of the information was given in the problem, but in this case, we are given the data and we have to find that information for ourselves. So what I want you to do is take a moment, pause the video, and go ahead and enter all this data into your list one. And if you forget how to do that, you go to Stat and Edit, and then enter all of that data in list one. Okay, now that you've entered the data in list one, what we're going to do is we're going to tell the calculator to do or find a confidence interval at 98% confidence using the data instead of plugging in the values that were given to us within the problem. So my information is in list one. I'm going to hit the Stat button and I'm going to go over to Tests. And I'm going to use not Z interval, I'm going to use T interval. And the reason is because we were not given the standard deviation for the population. That was not given to us. And I cannot get that information from a sample. So for this one, you need to put DNE. This is not given to us. Nowhere in here does it say the population standard deviation is. So when that happens, we are going to use a T interval. I'm going to hit enter on T interval. And I'm going to use data. See at the top, normally we would use stacks and we would put in all of our information. But this time we're going to use data and we're going to tell the calculator that we're putting it in list one. That's where we put our data, is in list one. Leave frequency alone. And our confidence level is 89%, so put that in as a decimal, 0.89, and then choose calculate, and we're going to get all of our information from the list of data that we entered in. Okay, now from the list here of data, the T interval is 9.49. That's the low end. I think it said round to two places. Yep, round to two places. So for the low end, we're going to put 9.49. And for the high end, or the higher, our upper limit, we're going to put 10.38. So that's going to go down here. Let me write that down. So we have 89% confidence. That's going to go here. And then our lower limit, we said, was 9.49. We got that from our confidence interval. And then the upper limit we said was 10.38. Now, we were also given, when the calculator calculated our interval, it also gave us our mean and our sample standard deviation and our sample size. So we can put all of that in here. And remember, this we do not know. It was not given to us. So this one I'm going to put DNE. Our sample size was 20. We can count that either from this list here, or the calculator counts it for us and puts it N as 20 here. And then for X bar, we're going to put 9.94 because the problem tells us to round to 4 places. So this is going to be 9.94. And then our standard deviation that the calculator gave us was 1.19. So this is going to be 1.19. And then our critical value, because we're using T interval, Now we're using t, not z, if we're using t interval. And to find our critical value, we have to find how many standard deviations away from the mean we are when we're looking at an 89% confidence interval. So 89% is going to go in the center here, which means that there is 11% left over. And if I split it up between the two wings, that's going to give me 5.5% in each wing. So we're not using z's now, we're using t's because we're doing t interval. So our t critical, we need to find that cutoff point, so we have 89% in the middle. So to find t critical, we're going to go under where the inverse norm is, and we're going to go to second vars, and instead of choosing inverse norm, we're going to use inverse t because we're using the t distribution. Now we put in the area to the left. It's 5.5%, so putting it in as a decimal would be 0.055. The df stands for the degrees of freedom. Since we have 20 data values, our degrees of freedom is one less than our data value, so this is going to be 19. And I'm going to hit enter. And our inverse t gives us that it's 1.6. We're going to round this to an 8 because this is bigger than a 5. So our t critical is going to be 1.68. So on this end, since it's below the mean, this would be negative 1.68. On this end, it would be positive 1.68. But when we're looking at just the difference between the center and the upper or lower limit, we're just looking at how far away we are, so we don't necessarily care about the negative or the positive in this direction. So we use the positive. Just the answer is 1.68.